The Story of Mel. This was posted to Usenet by its author, Ed Nather, on May 21st, 1983. Oh, this is gonna be so good. I'm ready. I'm excited. A recent article devoted to the macho side of programming made the bald and unvarnished statement, real programmers write in Fortran. Oh my, wait a second. Is this a reference to quiche eaters? What was it? Real programmers don't eat quiche? Is this Nicholas Worth? Right? Is this a reference to the reference of Nicholas Worth? I think so. Maybe they do now. In this decadent era of light beer, hand calculators, and user-friendly software. But back in the good old days when the term software sounded funny and real computers were made out of drums and vacuum tubes, real programmers wrote in machine code. It's true. If you look at the decades of the late 40s, 50s, and 60s and listen to and read through the change of just how much drum and mercury tubes and my goodness, it was wild. They didn't even have indirect registers for a decade. They couldn't even do pointers. It was crazy what they did. Prehistoric based, yeah, prehistoric. Not Fortran. Fortran was actually a pretty interesting invention, right? Because Fortran, its entire design was to combat this notion of a programming language being very, very inefficient. Because back then, in the 60s, and in the late 50s, when the first computer languages that were not literal machine code started to appear, the penalty for using them was immense, like absolutely immense. And so Fortran was created to try to be as close to machine code as possible so that you only had, like, say, a 1.1 reduction in speed. It was very incredible. The story of Fortran is very, very incredible. Uncle Bob is working on stuff that does with history, and I got to read some of it, and it talks a lot about the creation of Fortran, and it's amazing. Yes, 4chan. Fortran later became 4chan. That's why it's so barbaric. Fortran is an LLM consuming itself 4 times, and then out came 4chan. I know. Wild, huh? Barbarism. Crazy. Not Rafter, not even assembly language, machine code. Raw, unadorned, inscrutable hexadecimal numbers directly. Seymour Cray, hand-rolled, hand put in a front panel, bit by bit, an operating system directly from memory. The man was a legend. Lest a whole new generation of programmers grow up on the ignorance of this glorious past, I feel the duty bound to describe, as best I can through the generational gap, how a real programmer wrote code. I'll call him Mel, because that was his name. Okay, hey Mel. I first met Mel when I went to work for the Royal McBee Computer Corporation, a now-defunct subsidiary of the typewriter company. The firm manufactured the LGP-30, a small, cheap, by the standards of the day, drum memory computer, and had just started to manufacture the RPC-4000, a much-improved, bigger, faster, better drum memory computer. Cores cost too much and weren't here to stay anyways. That's why you haven't heard of the company or the computer. Fair? I've been hired to write a Fortran compiler for this new marvel, and Mel was my guide to its wonders. Mel didn't approve of compilers. By the way, this was also a very common practice in this day and age, which was if you wanted a language to work on a computer, then you had to write the compiler. So if there was not the RPC 4000 compiler for Fortran, whatever version of Fortran, you couldn't use it. Each thing, because like if you looked at the drum memory, even the drum memory was like, oh, this one's 72-bit words. Oh, this one's 17-bit words. Oh, this one's 37-bit words. Like just bizarre word size, right? It was just each one of them was like a do-it-yourself size of memory per access. It's wild. Okay. If a program can't rewrite its code, he asked, what's it good for? What good is it? Was the man advocating for AGI? It's either machine code or AGI. No in between. Mel had written in hexadecimal, the most popular computer program the company owned. It ran on an LG P30. By the way, he wrote in hexadecimal. Just let that sink in for just a moment, okay? No, wasn't Lisp. No, not Lisp. No. Hexadecimal. and played blackjack with potential customers at computer shows. Its effect was always dramatic. The LGP30 booth was packed at every show, and IBM salesmen stood around talking to each other. Whether or not this actually sold computers was the question we never discussed. Mel's job was to rewrite the blackjack program for the RPC 4000. Port? What does that mean? Imagine porting what you've written, raw-dogged into memory, onto a new machine with a new word length. You'd have to pad or remove so much stuff because it's like, oh, we're going from 72-bit to 64-bit now. Like, imagine what that would do to your hexadecimal. Crazy. The new computer had a 1+1 addressing scheme in which each machine instruction, in addition to the operation code and the address of the needed operand, had a second address that indicated where on the revolving drum the next instruction was located. Ooh, okay. In modern parlance, every single instruction was followed by a go-to. Hell yeah. Put that in Pascal's pipe and smoke it. Now that is the ultimate spaghetti. Okay? Mel loved the RPC 4000 because he could optimize his code, that is, locate instructions on the drum so that just as one finished its job, the next would be arriving in the read head and available for immediate execution. There was a program to do that job, an optimizing assembler, but Mel refused to use it. Oh my gosh, you could honestly rewrite this article as Copilot and me. The Primogen prefers to write his own sum function, even though there already is Copilot to be able to write the sum function for himself, but the Primogen refuses to use it. Damn it. It's literally me. Oh, I am being just in shambles right now. Gosh, you never know where it's going to put things, he explained, so you'd have to use separate constants. It was a long time before I understood that remark, since Mel knew the numeric value of every operation code and assigned his own drum addresses. Every instruction he wrote could be considered a numerical constant. He could pick up an earlier add instruction, say, and multiply it by it if it had the right numeric value. His code was not easy for someone else to modify. Oh my gosh. Dude, imagine not only are you writing code that's relying on previously used registers, like already for most people here, that would be an impossibility, including myself, by the way, to even debug a code like that. But to jump on top of it, the rotational speed of the drum for reads, as which register he was using. Impossible. I compared Mel's hand-optimized programs with the same code massaged by our optimizing assembler program, and Mel's ran faster. The encryption algorithms by TLS are hand-rolled assembly. I mean, to be completely fair, this still happens today, right? If you go into any of these really high performance needed areas, it's actually hand rolled because you can hand roll it the bestest. Just wait till you see hardware. I don't think I'm ready. Yeah, AES is hand rolled logic. Yeah, they're all hand rolled. I don't know. I don't know if I could handle hardware. I think I might be too emotionally bruised. That was because the top-down method of a program design hadn't been invented yet, and Mel wouldn't have used it anyways. He wrote the innermost parts of the program loops first, so they would get first choice of the optimum address locations on the drum. Oh, so brilliant. Then optimizing assembler wasn't smart enough to do it that way. I mean, it makes perfect sense what he's saying. This is, especially in a day where each instruction had a real cost. Like if you're running at 50 kilohertz maximum speed, 2 extra instructions per thing you're doing actually makes a real difference, right? Of course, the drum would, because the drum is the issue. Yeah, wait, Mel, hot-coded loops first? Yeah, I know. He literally hard-coded the hot loops first because he could see that far into things and then write the program backwards. Wild. Mel never wrote time delay loops either. Even when the bulky flexo writer required a delay between output characters to work right, he just located instructions on the drum, so each successive one was just past the read head when it was needed. The drum had executed another complete revolution to find the next instruction. He coined an unforgettable term for his procedure. Although optimum is an absolute term, like unique, it became common verbal practice to make it relevant. Not quite optimum, or less optimum, or not very optimum. Mel called it maximum time delay locations, the most pessimum. What the F is a drum? I don't quite understand what I know it's a pessimist, right? Casey Moratori used this, called it pessimizing his code, right? It just means the opposite of optimizing your code. It's not a fake word. A lot of people have used this word. I just don't. I'm too dumb to use it. But as far as I can understand when it comes to a drum, because I've only heard the term and seen it used in a couple contexts, there's some sort of read head that exists, right? That's reading something. And so for you to be able to get these instructions, you actually have a rotational speed, which we'll call like omega, right? And you actually have to read out these instructions, or you read out the memory. I don't quite understand it, and this is probably largely incorrect. It's a spinning magnetic drum. Yeah, it has something to do with that, and then it goes, and it's like a hard disk. It's like hard disk before hard disk. This was before SSDs. Yes, mostly right. I know there's probably something more to it that I'm completely missing. I'm sure maybe it has something to do with also verticality as well that I'm unable to understand, but I don't. I don't. Probably full of tape. Probably something to be filled with tape. But there's a time delay, so things can't just simply execute. So you can't just, and so if you can read an instruction and then the instruction takes so much time and the drum has moved far enough along, you can't read the next instruction, because what happens if the drum spins faster than this thing takes to execute? That's why I think there's go-tos. So that way you do the instruction and then you move the drum to the next location for the next one. So it's always slower, is my guess. That's just me working it out in my head. I could be completely wrong there. After he finished the blackjack program and got it to run, even the initializer is optimized, he said proudly. He got change requests from the sales department that the program used an elegant, optimized random number generator to shuffle the cards and deal them from the deck, and some of the salesmen felt it was too fair, since sometimes the customer lost. They wanted Mel to modify the program so at the setting of a sense switch on the console, they could change the odds and let the customer win. I know we just got done talking about games and that EU thing and then proposing all these changes and how it's going to be happening, and that's like a very large amount of effort. Imagine this. We're only asking to be able to improve odds. It was too even. Dude, you're telling me you're going to ask the guy who hand rolls the most optimized code to build in a cheat system? Ain't no way. Ain't no way this is going to happen. Mel balked. He felt this was patently dishonest, which it was, and that impinged in his personal integrity as a programmer. You literally asked the guy with the most amount of autism to quit acting autistic. Like, this is not going to, this just can't happen. The acoustic nature is just impossible. It's actually impossible for him to do this, which it did. And so he refused to do it. So head salesman talked to Mel, as did the big boss, and the big boss urging and a few fellow programmers. Mel finally gave in and wrote the code, but he got the test backwards. And when the sense switch was turned on, the program would cheat, winning every time. Mel was delighted with this, claiming his subconscious was uncontrollably ethical. Oh my! Wait, how is that uncontrollably ethical? Like, that makes the statement is even worse, because it's equally unethical. But I think the better one is just inability to recognize you messed up. You messed up. You got it wrong. You went left when you should have went right, and adamantly refused to fix it. After Mel had left the company for greener pastures, the big boss asked me to look at the code and see if I could find the test and reverse it. Somewhat reluctantly, I agreed to look. Tracking Mel's code was a real adventure. Oh yeah. I have often felt that programming is an art form whose real value can only be appreciated by another versed in the same arcane art. Oh, that's a lovely statement. This is a lovely statement, by the way. Yeah, true. True and factual. Imagine all this without debuggers. Imagine all this without, print.f. Ed Nather. That's a good tweet. That is a good tweet right there. That is a good tweet. There are lovely gems and brilliant coups hidden from human view and admiration sometimes forever by the very nature of the process. You can learn a lot about an individual just by reading through his code, even in hexadecimal. Mel was, I think, an unsung genius. The man literally wrote poetry without an LLM. Ed Nather is apparently also one of these geniuses. I don't know about this. Perhaps my greatest shock came when I found an innocent loop that had no test in it. No test, none. Common sense said it had to be a closed loop. Please tell me it was supposed to be for like delaying read for something else that allowed the drum to be set in a perfect position. Please tell me. Where the program would circle forever endlessly. A program control passed right through it. However, and safely out the other side. It took me 2 weeks to figure it out. The RPC 4000 computer had a really modern facility called an index register. Remember when I was telling you that there was no pointers? This right here. There was not point. Like, this is modern crazy right here. Being able to like store another address in a register and then being able to read through a register was like black magic. You should hear what I think Grace Hopper did this through a really bizarre set of hacking on the ENIAC, if I'm not mistaken. It allowed the programmer to write a program loop that used an indexed instruction inside. Each time through, the number of the index register was added to the address of that instruction, so it would refer to the next datum in the series. He had only to increment the index register each time through. Mel never used it. He don't need that shit. Instead, he would pull the instruction into a machine register, add 1 to its register address, and store it back. He would then execute the modified instruction right from the register. The loop was written so this additional execution time was taken into account. Let's go, I knew it! Dude, you can't tell me that's who Mel was and this loop not to exist. There's no way he did not write a series of instructions that were synced to the spinning speed. There's no way he wouldn't do that. Of course he was going to do it. Of course! Just as this instruction finished, the next one was right under the drum's read head, ready to go. But the loop had no test in it. The vital clue came when I noticed the index register bit, the bit that lay between the address and the operation code in the instruction word, was turned on. Yet Mel never used the index register, leaving it 0 all the time. When the light went on, it nearly blinded me. He had located the data he was working on near the top of memory, the largest locations the instructions could address. So after the last datum was handled, incrementing the instruction address would make it overflow. The carry would add 1 to the operation code, changing it to the next one in the instruction set, a jump instruction. Sure enough, the next program's instruction was in address location 0, and the program went happily on its way. Now, this is okay. Dude, no, stop with the RTFM business. Stop with that. This is crazy black magic. To use an overflow, weaponizing overflows for go-tos is crazy, okay? It's crazy. Don't even try it once with me, ever, okay? This is weaponization of overflows. And I would absolutely love to see Mel explain this. I would absolutely love to be walked through what Mel had created. I would love it. I would love every last bit of it because there's something that's just so amazing. Like what was the program called? It was Advent of Code 2020, 2019, one of the 2 years when they did the int computer. And the int computer for the Apollo was just wild and how it looped through things. It just like these raw-dogged ways in which computers worked. There's something very magical about it that just feels fun. Like today's programming I much prefer. I much prefer being able to build stuff easier, but the Scientology level science that was applied to the olden day modern programmers, it's just beautiful. It's beautiful. I haven't kept in touch with Mel, so I don't know if he ever gave in to the flood of change that has washed over programming techniques since those long gone days. I like to think he didn't. In any event, I was impressed enough that I quit looking for the offending test, telling the big boss I couldn't find it. He didn't seem surprised. It almost hurts a little bit. Not that the big boss assigned him such an improbable task, but upon assigning, big boss didn't even believe. You know, I think about this all the time. Like, I literally cannot help it. I think about this all the time. One of my first tasks when I was a youngster was in the C# application in which they got this. If Beast Coast here, he will tell you about this bug too, in which it would start trying to print these forms. And these forms, when attempted to be printed, you'd have to it would actually create every single image that was going to be printed. And it was like not a boom, but a receipt of everything that was going to happen of the transaction. And so to generate a lot of pages, and anything over, I forget what it was, like 30 pages would crash the production servers because it'd use too much RAM and it would crash the servers. This was back in the day when like 2 gigs of RAM was a lot, okay? And so we couldn't do that. And I remember going through it, and it used it stored the images in bitmap. raw dogged onto it, and I just look at it. And nowadays, I would so easily solve this. It would be so beautiful. Oh my gosh, I wish I could go back and just solve this problem given the previous constraints of exactly how it had to be stored and everything. Even something as simple as just an RLE on that would have solved it, because it's mostly white. It would have been so good. Just even like I could have hand rolled my own compression. And I look back on those days just wishing my youngness would have been more willing to do research. Well, the images were like receipts, right? So it's like one giant white page with some black text. Could have hand rolled my own. But I didn't. When I left the company, the blackjack program would still cheat if you turned on the right sense switch, and I think that's how it should be. I didn't feel comfortable hacking up the code of a real programmer. It was raw bitmaps. This was one of hackerdom's great heroic epics, free verse or no. In a few spare images, it captured more about the aesthetics and psychology of a hacking than all the scholarly volumes on the subject put together. But for a opposing point of view, see the entry, real programmers. Indirectly from the book, Real Men Don't Eat Quiche. Oh my goodness. Oh, I feel so happy. I feel so happy that we can just straight up, I could feel the sources happening. Mel never ate quiche, nor would I let him eat quiche. A particular subvariety of hacker, one possessed of a flippant attitude toward complexity that is arrogant even when justified by experience. The archetypal real programmer likes to program on the bare metal and is very good at the same time, remembers the binary opcodes for every machine he has ever programmed, thinks that HLLs are sissy, and uses a debugger to edit his code because full-screen editors are for wimps. Real programmers aren't satisfied with code that hasn't been tuned into a state of tenses, just short of rupture. I don't even know. I honestly don't even know what that means. Real programmers never use comments or write documentation. Okay, this is still true to this day. If it was hard to write, says real programmers, it should be hard to understand. Can we just be real here? That actually is really true. If something is really hard to write, it's really hard to understand. And people constantly try to do this like clever code is bad. Some problems like code is just hard. There's no getting around it. Right? There is absolutely no getting around the fact that it's hard, and you have to write crazy code. And like that's it. Real programmers can make machines do things that were never intended in their spec sheets. In fact, they are seldom really happy unless doing so. A real programmer's code can awe with its fiendish brilliance, even as its crokishness appalls. Real programmers live on junk food and coffee, hang line printer art on the walls, and terrify the crap out of other programmers. I believe we call this art users today, because someday somebody else might have to try to understand their code in order to change it. Their successor generally considered it a good thing that there aren't many real programmers around anymore. For a famous and somewhat more positive portrait of real programmers, see the story of Mel in the Appendix A. The term itself was popularized by a letter to the editor in July 1983, a datamation titled Real Programmers Don't Use Pascal, by Ed Post, still circulating on Usenet and internet in online form. This was right, just to be clear, Nicholas Worth, right? Oh no, that's who made this thing. Nicholas Worth, designer of Pascal, said that. You can tell, yeah. Or call me by value, Worth. Yeah, okay. So he was okay. My bad. I got them a little bit confused there. Absolutely beautiful. Copy the programming manual. Imagine actually having to, well, there's the drum. So this is what Mel understood. Mel, 3,700 RPM, 1 rev in 17 milliseconds. So that's what the loop was doing. The loop was literally timing out these sectors. And the drum must have been, each one of these had a certain sector, right? And so this thing would move along the this, whatever you call this axis, the x-axis, and read. Literally a loop. So the clock cycle was 17 milliseconds? No, the clock cycle wasn't 17 milliseconds. The revolution of the drum memory was 17 milliseconds, meaning that if you had to read one sector behind where you currently were, it would take 17 milliseconds approximately to get to the correct location before reading. So yeah, it's the read duration, the latency. It's the read latency. So your average read would take 9 milliseconds. I mean, 8.5 to be fair. So Mel, on the other hand, as far as we can understand, is he would time the program and where he wrote the memory such that as it finished each instruction, it would be able to read through the memory at really fast speeds. So he wasn't bound by the physical nature. He effectively created read access memory. Mel was like, drum roll, please. That was a pretty good one. But this is incredible, by the way. I wish I just had infinite time because I would love to see one of these programs and understand it. Maybe I'll try to track it down and we can go through all this because I would love to like truly understand all of this. This just seems like such an amazing, like even if we could only understand some of it, even the most basic of how he laid out stuff to be able to like slap memory as the thing was going. Yeah, he pipelined reads in a sense, kind of like hyperthreading did. Exactly. He just didn't have that ability. Yeah, RAM, rolling access memory. I'm gonna keep this in the cockles, as some would say. That's not a boomer loop. That's the greatest generation loop. That is a greatest generation loop. That is, for fact, the greatest generation loop. My boomer loops have nothing on the greatest generation loop. Dang. I hope Mel is still around, chilling in Aruba or something. Yeah, that'd be good. It would a life deserved. A life deserved. The cockles, a flashcard? No. Oh, more detail. Oh, yeah. Oh, there's so much more stuff. I wonder if there's like a deep dive on a lot of his stuff. Okay, I actually want to go through this because I genuinely think this could be like a pretty cool. I would just love to see the math, right? Like knowing how fast your CPU ran and to be able to do instructions at such a speed that you could time out rolling reads. It just sounds so impressive to have this like idea of rolling reads and everything. Anyways, hey, the name is the Primogen.